All right, well, I will begin with a word of prayer. Heavenly Father, we thank you for this day again. I thank you for this class and these students. Just ask you to bless our work today, help the students to prepare for their final exam in this class and the others, other classes that they're taking, that they would just use the time wisely this week, and that they just have a successful completion to this semester, Lord. In your name I pray, Lord Jesus. Amen.
Amen.
All right, I somewhere in here have, I forget which one it was.
Calculus?
Yeah, well, it's just I for whatever reason I put all my final exams. Here's what a lot of you have emailed me already, but let's see here. Technically, what is this class? This is you guys are section 4, right? So technically your final is Monday 1 to 3 on December 11th. So you either come to that or you come one of the other ones. If you don't do one of those two things, you have a 0. So I will not hunt you down. So make sure if you're going to one of the non-standard ones that you know where you're going to. I've put the room numbers here, right? Like they're not in this room, obviously. Like section 1 meets in DeMoss Hall 2082, which is the one of the classrooms right off the big room on the second floor, right across from the International Student Union. Calc 3 meets down the hall a little bit, like across from the math department. That's where 4166 is. 2052 is on the same hallway that 2082 is. It's kind of, I don't know how to explain where that is. You'll find it if you need to go there. So, any questions about this? Everybody clear? You got to take the final somewhere, right? Because
Can I take the final exam in the testing center?
if you'd like.
Yes.
All right. Well, could you email me, Michael? Remind me to do that for you. I'll probably remember anyway, but if you email me, it'll.
Because I need the extra time.
Yeah, that's fine. We could do that. If anybody else who has extra time and you want to take it in the testing center, do email me so I know. All right. Just let me know, and that way I'll send it over there. And all right. Any other questions about final exam? Time? What was the rule for formula sheets for the final? You're allowed 3 pages of notes, right? Usual rules, right? You can print it. You don't have to handwrite it. Whatever. But regular size paper, right?
Do they have to be in packets or pages?
They have to be 3 separate pages. I mean, they can be stapled together or something, but like 3 pages. It can't be part of a notebook or something.
Oh, so it's not a staple together, but
Well,
it's separate pages.
You could have 3 pages stapled together. That would be fine.
3 pages stapled together for, oh.
That would be okay, but they don't have.
No, I'm just saying 3 pieces of paper stapled together, combined. You get what I mean? Is not.
I think so. What I'm saying is that the only thing you couldn't do is say, I've got these 3 pages in a notebook that I'm going to use for the test. Like that wouldn't be okay. Like you can't bring a whole notebook into the final. Right? You have to have just 3 pages. Front and back is fine though. So I guess technically it's 6 pages, kind of if you count it that way. If you had 6 pages, single-sided, I would also be fine with that, to be honest. But then I kind of have to look at them. So it's just easier if we do double-sided. All right, where was I? I think I posted an old final for you guys, didn't I? Did I?
Oh.
You did. I don't think you made it.
Oh. Let's see here. Well, I think, well, I probably shouldn't look at that with you. I don't want to show you the final. That would be bad.
It's a surprise.
Let's see here before I accidentally show you the final.
How many questions are on the final?
Would it help you to know how many questions are on the final?
Yes.
Even if it's just a
I assume since it's 300 points, it's probably double that of a unit test.
Let's see here.
Though.
There are 22 questions on the final.
22 questions, no problem.
Are there like sub-questions in it too? Yeah.
Like A, B, C, D, E.
How many individual parts? You want to know like how many sub-questions, including it? All right, let me.
Are there sub-questions in it?
Yeah, of course. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. 38 separate information pieces, something like that. Give or take a range of a function or something I missed. Other questions? Is it comprehensive? Yes, like I can kind of give you a flavor for that. Problem 1, I give you a bunch of polynomials. I say factor the polynomials completely over the real numbers. If the polynomial is prime, then write prime in your answer. That's like question 1. All right. Problem 2, I give you like 3 different inequalities to solve.
Oh, can I write down the topics that I need to study?
Sure. Yeah.
Oh,
So like
Okay.
problem 2 is solve inequalities, give your answer in interval notation. Would you guys like me to review a couple of those? Let's do that.
okay.
Let me try something. How about like this? What if we were solving, say, x squared minus 10x plus 3, let's say greater than 0. How would you solve that inequality? What I would do is I would factor it.
Oh, oh,
And by factor, I mean complete the square.
oh.
Because factoring is not going to work. So really, this is x minus 5 squared. Looks like minus 22 greater than 0. And so if I factor that, what I'm really up against is x minus 5 plus the square root of 22, parentheses, x minus 5 minus the square root of 22 greater than 0. So what are my critical numbers here?
So,
I've got 5 plus or minus the square root of 22. Now the square root of 22 is somewhere between 4 and 5, right? So if we think about that, we've got something like 5 plus the square root of 22, and over here, 5 minus the square root of 22. Those are my 2 critical numbers. Think about what you're doing. You're looking at a quadratic that opens up, right? If you just were to write y equals 10x squared minus 10x plus 3, that's a quadratic that opens up. So you can kind of expect the sign chart. It's going to be pluses, minuses in the middle, right? I mean, if you think about this graphically, what is that? It's something like this, right? So it should go plus, minus, plus for this example. All right, so what's my solution? Looks like I've got minus infinity to 5 minus root 22, union with 5 plus root 22 to infinity. Do I include the critical numbers or exclude them? What do you guys think?
You know what? I think,
I currently have excluded them, am I right? Or do I need to turn those parentheses into brackets?
I think you exclude them.
So keep it the way it is. Why is that? Because this is a strict inequality, right? So we're not including equals 0, so we don't make them brackets. So there you go, that's the answer. Let's do another one. Example 2, what if we're up against something like absolute value of 3x minus 11 plus 3 greater than, well, 2. How would that go? Everybody should be able to solve this problem before I get back to the board.
Okay.
This one's silly. This one's just silly. Subtract 3 to the other side. What do you get?
-1.
-1. Is the absolute value of 3x minus 11 greater than -1?
Well,
Is absolute value ever negative?
no,
No. So the answer here?
is no solution.
The opposite.
Extraneous.
So the solution is everything. Because the absolute value is greater than a negative number. That's a tautology. That's always true. Now, example 3, if I had instead like 3x minus 11, less than -1. Now this one, I would say no solution. All right, that's what you guys are thinking about, this kind of problem. That has no solution because it's impossible for the absolute value to be negative, right? Let's look at one that's actually interesting. All right, so example 4. What if we're up against something like absolute value of 3x minus 11 plus 1 greater than, let me make that a plus 11, greater than 20. Okay, now that one, that's more interesting. See, because then we're up against the absolute value of 3x minus 11 greater than 9. How do you solve this kind of problem? Do you guys remember? Yeah, Michael?
Negative infinity, 9 to infinity.
Oh, no. I mean, maybe. Maybe, but we have to break this into two pieces. On the one hand, we could have 3x minus 11 less than minus 9, or we could have 3x minus 11 greater than 9. There are these two separate cases we have to deal with. And you just got to wrestle with them separately. All right? And what Michael said might be true. I just don't know without working it out. So that's like 3x less than 9, minus 9 plus 11 is 2, I think. And here you got 3x greater than 20. So we either have x is less than 2/3 or x is greater than 20/3. So the solution is minus infinity to 2/3 unioned with 20/3 to infinity. It's been a while since we did these problems in here, right? Let's do one more just to make sure we have all of the bases covered. What's the other thing that can happen with these kind of problems? Do you guys remember? What if I have something like absolute value of 17x plus 3 is less than 10? How would you solve, I'll throw equality in this time, less than or equal to 10. How would you solve that? One of the things that absolutely should be on your formula sheet is a clear reminder to yourself that the absolute value less than and the absolute value greater than problems are different. They require a different approach, a different strategy for their solution. If we have greater than, we have to separate into two cases. If we have less than, we can rewrite the problem as a so-called compound inequality, which I'll write down just now. So what we do is minus 10 less than or equal to the thing inside the absolute value, less than or equal to 10. All right, so this we can solve by minus 10 less than or equal to 17x plus 3 less than or equal to 10. And you solve this, right? Subtract 3 across the board, what do you got? Minus 13 less than or equal to 17x less than or equal to 7. And then, what? Divide by 17. So we get minus 13 over 7 less than or equal to x less than or equal to 7 over 17. So my solution is minus 13 over 7, comma, 7 over 17. All right? So there's these, the less than problem and the greater than problem for absolute value. They're really different, right? And of course, you have the silly cases to keep in mind, but I don't always test on those. It's just that could happen, right? What's the other kind of inequality we solved in here? Do you guys remember? Like rational inequalities. We did those as well, right? Something like, let's see here. I'll do a relatively simple one. Something like x minus 3 divided by x squared minus 4, let's say less than or equal to 0. How would we solve this? Well, you need to find all the critical numbers, right? The places where either the numerator is 0 or the denominator is 0, right? And so this is the same as x minus 3 over x plus 2 times x minus 2 less than or equal to 0. And what are my critical numbers then?
3,
Uh-huh.
negative 2, 3, and 2.
Negative 2, 3, and 2. Right. Now make sure you put them in order, right?
I got it.
You got it? Michael's got it? Somehow people are rocking out to my lecture. I don't know what's happening. Somewhat disturbing. Should be like mirrors in the front of the class so everybody can see what everybody else is doing all the time. It'd be fun. That could be distracting, I suppose. Yeah. So we need to check some points, right? So if I put a large positive number, I've got plus plus plus. So I start out positive over here. Each one of these has multiplicity 1, so that we flip the sign each time. So I'm trying to solve less than or equal to 0. What's my solution then? Minus infinity to minus 2. Well, I don't know if I should include. What do you guys think? Should I include or exclude minus 2?
Exclude,
And why is that, Michael?
because it's on the denominator.
On the denominator, that's right. Would give us division by 0, which would not be good.
Is
Right.
undefined.
Yeah. And then we get to 2, again from the denominator, so we're going to exclude it. And then we get to 3. Well, 3 is fine. We'll include that because that just makes it 0. So there you go. That's the solution set in this case. This is how we solve polynomial inequalities or rational inequalities. Find all the critical numbers, draw the sign chart, and write the solution down. All right? Any questions before I go on? Yeah.
Can you show me what the rest of the 20 questions are going to be on?
Yes, we can go on, Michael. The next problem is something about a case-wise defined function.
Question.
You guys remember the case-wise defined functions? It's just like one of those. The next problem is just solving some polynomial equations. Let me make up some. We could try to solve those, right? Let's see here if I can make up one. Bah. So you guys know the drill. Like, if you're solving an equation, the answer is either hey, there's no solution for an inequality. The solution tends to be a whole infinite set of numbers, so we have to use interval notation to get the whole solution set. to an inequality. But for an equation, for a polynomial equation, for an nth order problem, there are going to be at most n solutions, possibly complex, possibly repeated, for a polynomial equation. So there's that. On the other hand, if the question is to factor the polynomial, the answer is an expression, right? These are separate but related problems. So example 7, I suppose we might be up against something like, oh, here's one you might have forgotten about. X cubed plus 3x squared plus 3x plus 1 equal to 0. This one's kind of tricky. But you may remember this is actually x plus 1, what? X plus 1 cubed, right? That's the special form trinomial. So that equal to 0 just has one solution. What is the solution?
-1.
-1. Very good. Let's look at a different example. What if we're up against, suppose somebody tells you 2x minus 3 squared is equal to minus 42. Can you solve that? How many solutions do you expect? Now, if somebody asks you that question, they're probably going to say, you know, like if I ask that question, I'm going to be allowing complex solutions, right? If I was to say solve it, find any real solutions, then the answer is easy. The answer is no real solution because we can't have a real number square to a negative number, right? So there's solutions here, they got to be complex. But to solve that, we do what? We just use the square root property, right? So this gives us 2x minus 3 is equal to plus or minus the square root of minus 42, which you could rewrite. That's right, I root 42. And so we get 2x is equal to 3 plus or minus I root 42, which I can finally solve for x is 3 plus or minus I times the square root of 42 divided by 2. Now, you know, if you're a stickler for, if you have like some kind of OCD when it comes to square roots, you could simplify that, you know, possibly 42 is like 6 times 7, maybe, I don't know, maybe that's simple enough, I guess. I'm not sure anything really pulls out of that. Anyway, that's an answer. There are two answers. They're both complex. Let's do another. What if we're up against, I'll write it out here for you guys. What if you're up against something like, oh, I don't know, x cubed minus 5x squared plus 6x equals to 0. Could you solve that? So the answer to like these sort of polynomial equations is, in order to solve it, you really want to factor it, right? Because if you can factor it, then you can use basically the factor theorem, which says to each 0 there corresponds a factor. And so if you can factor it, you can just read the solution right off the factoring of it. Can you factor that?
Yep.
Where would you start? What's the easiest thing to do?
Factor out the x.
Factor out the x. Very good. Now you're like, whoa, I mean, that's easy. I'll tell you what, that's easy if you see to do it. But if you don't see to factor out that x, you're kind of dead in the water for this problem, right? Like that's really, really important to think about the x. The fact that you can factor out an x, it's a big deal. Anyway, so x times x squared minus 5x plus 6. And can that factor?
Yes.
How so?
X minus 3 times x minus 2 times x.
Ah. So did we need to complete the square this time?
No.
No, not really.
We can factor it.
That's right. Now, if you completed this square, would you still got the same answer?
Mm-hmm.
If you can do it correctly, then yes, right? But there you go. So what does that make the answer? This is not the answer. This is just factoring, right? To solve the equation, so my solution, what is the solution here?
Find the critical number.
The solutions are x equals to 0, 2, and 3. It's a third order polynomial, and we find 3 solutions. Let's see here. The next problem, since Michael wants me to move on, it involves like an equation involving radicals. Solving an equation involving radicals. Do you guys remember how that went? Now this is not the problem, but here's one. What if you're solving like the cube root of x minus 2 equals to 3? How would you solve that?
Here's the third power both sides.
Oh yeah, cube both sides. So we get x minus 2 is equal to 3 to the 3, also known as 27. So x equals to 29. But we also had more interesting ones, like x minus the square root of x equals to 10, stuff like that. How do you solve something like that? What I would do is I would isolate the radical, right? So I get x minus 10 is equal to the square root of x. I'd isolate the radical, and then I square to get rid of the radical. Squaring gives me x minus 10 squared equals to x, which is x squared minus 20x plus 100 equals to x, which is x squared minus 21x plus 100 equals to 0, which I don't think factors nicely, right? So I've got like x minus 21 over 2 quantity squared minus 21 over 2 quantity squared plus 100 equal to 0, blah, 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 blah. All right. We can solve that quadratic. That would be the answer. I think only one of them is actually a solution. I think the other is not. So this one would have like an extraneous solution. Let me see here. Then I have an exponential, like an exponential kind of equation. Oh man, something that stopped a lot of you guys cold in your tracks. And like this was not meant to be a trick question on test 3, but my goodness, it was. Like this question here on test 3, this stopped you guys, so many of you. Like 2 to the x equals to 3 to the x. That was not supposed to be a trick question, but it confounded many of you. Like over half the class just got totally stuck on this. So let me go through it. We take the natural log of both sides, and we bring x down, and a lot of you got to here, and then you just didn't know what to do with it. But what you do with it is just bring everything to one side and factor out the x. The thing is, natural log of 2 and natural log of 3, they're not the same number. So what are you looking at? You've got x times a non-zero number equals to 0. What's the solution? The solution is simply x equals to 0. See, if I have x times something non-zero, it must be that x is 0. And once you go through that algebra and you look back at the original equation, you should be like, oh, I could have guessed that, right? Because any exponential, if you plug in 0, what do you get?
0.
You get 1. A to the 0 is 1, whether a is 2 or whether a is 3. So this solution, you could have guessed. You're like, well, okay. Anyway, hopefully many of you will replace your third test grade with the final exam score, right? The next problem, Michael, is like graphing match graphs. The next problem is find the coordinates of the vertex of a parabola. There's one where I ask you about graphing a rational function. There's one where I ask you to create the formula for the polynomial given the graph.
What was question 6 again?
Question 6 was like a match
the graph.
Match the graph, yeah. I just made an announcement, guys, about grades. Have you guys read it?
I read it, but it didn't make sense.
It didn't make sense? Yeah.
How would you submit the course survey?
That's
Is
like
it-
the end of course survey.
Isn't the
pops
end-
up in
the end
Canvas.
of-
I mean, like, you said for extra credit, like, how would she show you that we did?
Oh, you don't have to prove it to me. I'll know.
You don't know.
I'm like Santa Claus.
Awesome.
It's not really true. I'm just crediting everybody for the course survey. I assume that you do it. That's 30 points for free. It's true. There's no way I can individually check who's done the survey or not. Anybody who says they can is lying to you.
No, they just say it's
One year we could. There was a year I could see who done the course survey as they came in, and I could look at them in the same time.
Oh, cool.
That was a nice year. That was fun. That's just a one-off though. Like, they fixed it the next semester.
Unfortunate.
So,
That was fun.
say about,
Okay, so problem 7, find the vertex of parabola. Problem 8 is graphing rational functions. Problem 9 is create the formula for a polynomial given a graph. Problem 10 is like solving, it's like simplification of or solving a logarithmic exponential equation, something like that. Problem 11, another like natural log or exponential equation. Problem 12, another like natural log or exponential equation. So in other words, problems 10, 11, 12, and 13 are kind of like equations you might have seen on test 3, to summarize, okay? Problem 14 is a simplify rational expressions kind of question, like you would have seen on test 2, I think. I think we did those on test 2, maybe test 1, I can't remember. Problem 15 is a solve a rational equation problem. Problem 16 is long division. Problem 17 is one of those, you've got ABC, you got to find the ABC for the power function kind of things. Problem 18 is kind of sort of new, but you should be able to solve it on the basis of things you've learned in this course. Problem 19, 3 equations, 3 unknowns. Problem 20 is find the inverse formula. 21 is solve, it's another, it's like a test 3 kind of question. And then problem 22 is another find the formula for the inverse test 3 kind of question. Yeah, that's it. So it covers everything. It's the full, that's everything, pretty much.
Can you send me the whole, hey, what's going to be on the test? I felt sleepy.
You could just listen back on the YouTube video for it.
Can you send me the YouTube video then?
It's in the, I will post it in the,
And then search
Cook
up
math.
Super Math.
if you look back at the announcements for the course, there was like the first announcement I made had a link to the playlist, and this will be the last video in there. Well, anyway, it's been fun, guys. So, you're the best section 4 of college algebra I've taught this semester. All right. Thanks, guys.